Hello students, today we are going to continue what we left in last class. Okay, so the last class we have studied the covalent character in ionic character in covalent bond. Okay, so today we are going to learn the covalent character present in ionic bond. Okay, covalent character, covalent nature in ionic bond. So how sir ionic bond may have the covalent character, right? Is it possible? Yes. See, usually what is ionic bond? One cation, one anion. Cation will donate the electron. That means already it is donated. That's why it becoming cation. Okay. For example, if you take sodium chloride, sodium will give electron. Chlorine will accept electron. So Na plus Cl minus, they will form bond between them. It is called the ionic bond. Okay. So in this attraction, we have small covalent character also. How the small covalent character comes, we will see now. Because of polarization, the phenomenon polarization helps to find the covalent character in ionic bond, right? So polarization means what? The polarization, the positive negative ions having some polarizing power, right? So we will see what is polarization. If you take one cation and anion, both, right? So cation overall which having positive charge, anion having negative charge. Okay, so this positive charge will attract the electron cloud in the anion. We can say this is cation anion, right? So this cation attracts that electron cloud in anion. So because of that attraction, the anion electron cloud will move towards the cation. Because of that movement, the shape of the anion becoming oval shape. See, next what will happen? This is cation, right? Anion will form like this. Okay, so because of this force of attraction of cationic charge, the electron cloud comes nearby the cation. So the electron distorted from its place. This is called polarization, right? So normally it may exist a separate spherical shape. Because of this polarizing power of this cation, the electron clouds are attracted towards the cation. So this is called polarization. So who is the polarizing ability? Who is having the polarizing ability? Cation. That's why the cation having the polarization with the anion. This is the anion. So anionic electrons are attracted by cation. That ability is called polarizing ability. Okay, what about the anion? Anion undergone the polarization. That's why that is called polarizability. So you may think both are same. No, polarizing ability is different from polarizability. Polarizability means which undergo the polarization. Which one is giving the force to polarize, that is polarizing ability, right? This phenomenon, this process, polarizing process is called polarization. Okay. So by knowing this polarization, we have to follow certain rules according to Fajans. The scientist's name is Fajan. So the Fajans give so many rules to learn the covalent character of ionic bond. So in the ionic bond, we have the covalent character. What are the rules? First rule: the cation anion should have the high charge. Cation which having high charge. Anion also high charge. So it will have high covalent nature. Upward or not means you think that is denoted high. Okay. Then cation anion charge high means how the covalent bond becoming high. You can see one example. If you take lithium chloride, sodium chloride, element lithium, sodium chloride, magnesium chloride, and then aluminum chloride. If you see among all are ionic compounds, but the charge of sodium plus magnesium 2 plus aluminum 3 plus, which are having more charge? Aluminum. Because of that, aluminum having more polarizing ability than magnesium, then sodium. So why aluminum having high polarizing nature? High charge 3 plus, then 2 plus plus 1. So high charge means it will have more covalent character. Then second rule. What's the second rule? We are going to discuss about size. Size of cation. It should be smaller. Anion larger. Cation smaller means what will happen? It will have more covalent. Anion larger means it will have more covalent. So that is a condition to get more covalent nature, right? So example we will see lithium chloride, sodium chloride, LiCl, NaCl. If you compare the size, lithium having smaller size, sodium having larger size. Size of lithium is smaller than that of sodium. So which one having smaller size, that will have more covalent character. So lithium chloride will have more covalent character. Sir, we didn't discuss about anion size. Both are same anion. So both will have same size. So only the polarizing ability depends upon the lithium or sodium. So lithium chloride will have more covalent character. That's why it is soluble in water. Then third point. Here also we can compare the anion charge. The sodium lithium chloride is compared with lithium iodide. If you see, the anions are different, cations are same. Now chlorine having smaller size than iodine, so lithium iodide will have more covalent character because iodine having larger size. For anion part of it, large size should be larger, then we will get more covalent character. Then the third one. What's the third one? We have to think of that the electrons. Smaller cation, larger anion over 1 minute. Electronic configuration. What do you mean electronic configuration? The cation having Ns2, Np6, Nd10 electronic configuration is having more covalent character than Ns2, Np6 electronic configuration. Here also we can take example sodium chloride, copper chloride. So sodium chloride, sodium having smaller size, copper having larger size. Sodium having larger size, copper having smaller size. So that rule we can follow. Otherwise, we can compare the electronic configuration. Sodium Na plus, if you take it 1s2, 2s2, 2p6, but copper plus 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 won't come, 3d10. See, this 10 completely filled electronic configuration comes for copper. So copper chloride having more covalent character than sodium chloride. So these are the three rules to follow the Fajan's rule. So according to the Fajan's rule, we can find the covalent nature. So the conditions also given. If any compound follows this condition, that have the more covalent character. Next, we are going to learn about valence shell electron repulsion theory. That is called VSEPR theory. VSEPR theory. What do you mean VSEPR theory? Valence shell electron pair repulsion theory. Valence shell electron pair repulsion theory. What do you mean that? Valence shell electron only, that last shell electron only plays important role in this theory. Okay. Then already some of them find the shapes of compound. For example, Lewis dot structure itself given so many idea about shapes of compound, but we cannot have the clear idea about shapes of all the compound. That's why we need this valence cell electron repulsion theory. So what are the following things we have to know to find the shapes means? First one is we have to find the valence cell electron. So valency cell electrons only plays the important role to find shape. If you want to find the shape, you must know valence cell electron. Second, the valence cell electron, two types of valence cell we can find. One is a lone pair electron, another one is a bond pair electron. What do you mean lone pair? What do you mean bond pair? Lone pair means which is present in the valence cell but which is not involved in any bond formation. Bond pair means bonded electron. For example, if you take water, hydrogen having only one, oxygen having 6 valence electron. One will give for this hydrogen, another one will give for that hydrogen. Remaining you have 4, so it can write as a 2 lone pair. So these electrons are called bond pair. These electrons are called lone pair. Okay. Then if you see the valence cell electron, the valence cell electron always try to keep the distance between them because electron repulsion, the valence cell electrons are located in as far away to each other. So to maintain the stability, the electrons should keep the distance between them. Okay. Then the last one, we have the two pairs, which one having more repulsion. Repulsion force is there, so they are keeping the long distance. Suppose it is coming closer means which type of electron having the more repulsion means we have the sequence. Lone pair having more repulsion, then lone pair, bond pair, then bond pair having repulsion. According to the sequence, we can have the repulsion, right? Lone pair having high. Why lone pair having high repulsion force? Why lone pair, bond pair having low? See, lone pair electron only belongs are located with the only that particular atom, but bond pair shared by two different atoms. Because of that, lone pair having high force of attraction, repulsion. Usually lone pair we will denote with loops. If you consider oxygen having two lone pair means two loops you will draw. Okay. By using all the four, we can see the shapes of many compound. Actually, for that you should use the book because we have many shapes, and also we have to learn how the compounds are arranged. What are the symbols of compound, right? So take page number. If you have book, please during this video, all of you take your book, page number 82, 83, 84, right? See here, so many shapes are given. Before that, we must know what are the types of compounds may present. See, one atom A, another atom B. They are combining means we will get AB molecule. The same way, A, B, one more B may present. So AB2. Then AB3, AB4. So 1A, 3, 4, 3B, 4B likewise it may form. Otherwise, it may have the lone pair electron. Suppose AB2 having one lone pair electron means we can represent AB2L, which having AB3 having two lone pair, 2. No lone pair, simply we can write AB. So these are the types of compounds, right? Next we will see some example for all the types of compound. So first, very familiar, beryllium chloride. If you take it forming the linear structure. What is linear structure? The middle atom beryllium, one side one Cl, another side another Cl, which having 180 angle. So this is called a linear structure. Okay. Then we can take triplanar, right? Conal planar. What do you mean triconal planar? We take example BF3, boron trifluoride. Boron F. So it's forming trigonal shape, but it's place in the plane. So trigonal planar. Then we may write for a bend shape, right? So example, sulfur dioxide, SO2, if you take SOO, so it will form bend shape, this like V shape. We also called V shape, right? Why, sir? It can form straight bond, because of this lone pair electron which having lone pair electron, because of the lone pair bond pair repulsion which having bond pair. Here we have lone pair, because of that interaction or repulsion which forms V shape. Okay, then pyramidal shape, tetrahedral shape. Tetrahedral shape means we can have familiar example, CH4, one carbon, one hydrogen, second, third, fourth. So it will form like this structure. This is called a tetrahedral structure. Okay. Then trigonal bipyramidal. First we will see ammonia, pyramidal shape, nitrogen, H, H, H. So like pyramid shape is having lone pair. So pyramidal shape. Then we will see trigonal bipyramidal, phosphorus pentachloride, PCl, Cl, Cl. It will form one trigonal. The top one Cl, bottom one Cl. So you will get the trigonal bipyramidal shape. This is called a trigonal bipyramidal shape. Then we can have the octahedral shape. What is octahedral shape? IF7 we can write. I hope. Sorry, S of 6. S, F 1, 2, 3, 4, fifth one, sixth one. So square pyramidal. Only one side we have pyramid means we will say square pyramidal. Both side means octahedral structure. This is called octahedral structure. Then we may have pentagonal bipyramidal. Best example, IF7. F. We have iodine. So one F, bottom F. So we have pentagonal bipyramidal shape. So likewise we have many shape, right? So all those we can learn by using BSEPR theory. Next we are going to learn about valence bond theory. Valency bond theory, VP theory. Usually I will say VP theory, that's why I couldn't say, right? VP theory, valency bond theory. So valence bond theory also explain the shapes of a compound and their interaction. Okay. So the two scientists Hitler and London drawn that valence bond theory. Okay, valency bond theory. See, actually based on the wave mechanics they are trying to bring this theory, but we cannot go with all those things. So we can learn all the wave mechanics things in the higher studies, right? Now we will learn with smaller molecule like hydrogen, H2, right? So if you see one hydrogen is another hydrogen, they are far distance, they are in infinite distance, means they are having stable electronic configuration, they are zero potential energy, they don't have any repulsion or attractive force. But when they are approach each other, they will face two type of attraction, two type of repulsion. If you draw this nucleus, hydrogen A, hydrogen B. Now you can expect two repulsion, two attraction. There are valency electrons. Now what will happen? This nucleus will repel each other. These electrons will repel each other. Two repulsion force. Two attractive force also we can expect. What are they? this nucleus may attract this electron, this nucleus may attract other electron. So you can write what are the two attractive force. HA nucleus will attract HB electron. HB nucleus will attract HA electron. What are the two repulsive forces? HA nucleus repels HB nucleus. HA electron repels HB electron. So when these four attractive and repulsive forces balance each other, then only they will make bond and stable molecule will form. Okay, so how will you find if they are in stable state? Okay, so for that we must know the distance, bond length between them. Okay, so that's why we are learning valence bond theory. So for hydrogen molecule, what's the accurate distance between these two nuclei? 74 picometer. Then 436 kilojoule mole inverse is the bond energy or potential energy of this hydrogen molecule. For that we can draw the graph also. Here potential energy, here bond length. Then at 74 bond length, here 436, only the correct length to keep the stable hydrogen molecule. It will start from the high potential energy, then they will combine, it will have minimum energy. Again if you go closer, again the potential energy will increase, they will repel each other. See, they are far away means no repulsion, no attraction. They are going closer means repulsion will come. So when we are keeping the correct distance, it will form correct stable molecule. That is 436 kilojoule mole inverse potential energy and 74 picometer. Right? Remaining we will see in the next video. Thank you.